good day everyone. I welcome you to another episode of CHM 111, and in this particular video I want to run through this functional group, which are the nitroalkane, the amine, the nitrile, the thiols, the sulphide, and the sulphones. So let me quickly pick the nitroalkane group. The nitroalkane, they have the general formula of RNO2. Please take note of the formula. This is nitrogen 4 oxide directly bonded to an alkyl group, so we call this the what? The nitro group. So wherever you see something like this, always take note of this, the nitro group. And remember, this arrow simply means Cn, the H2n plus what? Plus 1. So this is the arrow. Then we already know that the first member is CH3, second member is C2H5, the third member is C3H7, the next member is C4H what? H9. Let's stop here. So in the situation whereby you have CH3 bonded to NO2, please, this is what we call, remember, is a nitroalkane. So we call this nitromethane. So the name of this compound is called what? The nitro what? Methane. Then assuming here is C2H5, which is the second member of this series, then it's now called what? Nitro what? Ethane. So for the third member is now called what? Nitropropane, nitrobutane, nitro. So first of all, you are going to start with the nitro group before the other names we do what we come in. So the next functional group we have there, they are the amines. Please take note. There is difference between the amine and the amide. The amine has the general formula of R bonded to NH2 bonded to, which is amine. Then for the amide is RCONH2. So there is a carbonyl functional group or a C2O functional group, carbon double bonded to oxygen functional group for amide, but that's not present in what? In amine. So this is a very great difference between the amine and the amine. Amine is carbonyl, but amide is carbonyl, but amine is not what? Carbonyl. These are an alkyl group directly bonded to what? To amine, which is NH2. This is an alkyl group directly bonded to carbonyl, directly bonded to the what? The amine. So please take note of this. So the first member of the amine is let's say CH3 NH2. In this compound, we can call them amines. We can also call them alkamides or aminoalkanes. I've given you three names already. You can call them the amines functional group, you can call them the alkamides functional group, or the aminoalkane what? Functional group. So for example, the first member here will now be what? Aminomethane. The second member will be aminoethane, aminopropane, aminobutane, amino. Make sure that everything you are doing start with amino before the other functional group will do what? You come up. So that is exactly what you are supposed to know about the nitroalkane and the what? And the amine. Please take note. There is a difference between amine and amide. Amine has a direct bond between carbon and nitrogen, but amine has a direct bond between carbon and what? Carbon to oxygen before carbon to what? To the nitrogen functional group. So this is something you should take note of. Don't confuse them. Amide differs from what? From amides. The next functional group we're dealing with in this series is the nitrile functional group. The nitrile functional group, they have the general formula of RCN, and this CN simply, the full functional group is called nitrile, but this CN simply means cyano. The cyano what? Functional group. So please take note of this. Now, as long as this, it looks like this, which is arrow single bonded to carbon, triple bonded to what? To nitrogen. This is how the functional group looks like. So, but there's something I want you to take note of. As long as here is R, which is an alkyl, it can be CH3CN or C2H5CN. So we call this, remember, we cannot call this methane because there's a carbon atom here. So it is earth. It's already 2 carbon atoms. Here is 2 carbon atoms plus this one will make it 3. Here is 1 plus this 2. 2 plus this 3. So here is called propano propanonitrile, and here is what? Ethanol what? Nitrile. So all of them we have O nitrile at the end of it, O nitrile at the end of it. So we have propanonitrile, ethanonitrile, butanonitrile, pentanonitrile. So that's how all of them looks like. So they have the R bonded to cyanofunctional group, CN, carbon triple bonded to nitrogen. So please, we call all of them what? Nitrile functional group. Then the next one we'll be dealing with is the thiols. Thiols is the same thing as, it's not really the same. Okay, we believe that ROH is an alcohol, right? So if ROH is an alcohol and this oxygen and alcohol is replaced by sulfur, the oxygen is replaced by sulfur, the functional group that is going to produce is called what? The thiols. So whenever the oxygen in alcohol is replaced by sulfur, is going to form what? The thiols what? Functional group. So and if this place is replaced by methyl, ethyl, that's for the ion pack nomenclature. Let's say if you have something like CH3, then bonded to S and H. So if you have something like this, it's now called methane thiols. So if you C2H5, it's called what? Ethane what? Thiols. But please take note, thiols are actually formed from the replacement of the oxygen in an alcohol by what? By sulfur. So in that situation, the product that will be formed from that reaction is called what? The thiols functional group. That's where you are going to see your thiols what? Functional group. Okay, let's quickly rush through the sulphide. Now, if you look at this compound here, you already know that this compound is a thiols because of this functional group, sulfur to hydrogen functional group, and this is a haloalkane because of this bromine. Then this compound we don't know. So, but as long as there is an R directly bonded to S, directly bonded to R, which is an alkyl, we call this a what? A sulphide. A sulphide. So please, when a thiols reacts with a halo group, please let me write it. When a thiols reacts with a haloalkane, the product that will be formed is called what? The sulphide. So an example of this reaction is this is a methyl thiols, methane thiols rather, not a methyl, a methane thiols. Then this is bromoethane. Then when methane thiol reacts to bromomethane, it's going to give us a methyl. Then you come to this one, ethyl sulphide, which is methyl ethyl what? Sulphide. So that will be the product that will be formed. What about if you now have, let's say here is CH3 bonded to SH plus CH3 bonded to a B arrow, or let me remove that and put chlorine here to give us CH3. Here will give us S, then plus what? CH3, whereby this H and the chlorine, they are going to form hydrochloric acid. This H here and the bromine, they are going to form hydrogen bromide. We don't need all of those. So what is the name of this thing? This is called methane thiols. This is a methane thiols. Then this is a chloromethane. A chloromethane. When methane thiol reacts with a chloromethane, the answer will be a what? A sulphide. And what kind of sulphide is that? Is this? We can call this a methyl sulphide. So as long as it is methyl and here is methyl, it is easily called a dimethyl what? A dimethyl what? Sulphide. So that will be the name. What if you have something like C2H5 bonded to S bonded to C2H5? Here is ethyl what? Sulphide, which is also known as diethyl sulphide. So what about if you have CH3 and here is S and here is C3H7? Here is methyl propyl sulphide. C3 is propyl. What about if here is C3H7? It will not be propyl sulphide, but as long as here is propyl, it will be called what? Dipropyl what? Sulphide. And it is under this group here. So please take note of that. Here is not supposed to be H, here is supposed to be S. Please Take note of that. So sulphide is usually a sulfur between, is more of a, I don't know if you still remember this functional group, ROR. So if you replace this oxygen with this is an ether. This is an ether. So when the oxygen in ether is replaced by sulfur, please when the oxygen is ether is replaced by sulfur, it's going to give us what? Sulphide. And when the oxygen in alcohol is replaced by sulfur, it's going to give us what? Thiols. So for sulphones, let's quickly look at this. We believe that this is a sulphide because of the functional group. So here is a sulphide. And if you oxidize sulphide in the presence of hydrogen peroxide, it's going to give us a sulfoxide. A sulfoxide. And this sulfoxide, if you further oxidize it, it's going to give us a what? A sulphone. A sulphone. So the complete oxidation of sulphide will give us what? Sulphone. So but the partial one is going to give us sulfoxide. Let me give you the full name. Here is methyl, here is ethyl, here is ethyl. So we call this diethyl what? Diethyl sulfide. And there is hydrogen peroxide, Here we give us see the same thing, diethyl sulfone. Sorry, sulfoxide. Here is the sulfoxide. Then here we give us a what? A diethyl what? Sulfone. So it can also be methyl ethyl sulfone. So based on how the compound is arranged. But if you have something like R prime SO, sorry, R SO, R prime, SO2 please, R prime. Now you know that the alkyl here differs from the alkyl here. That's to say, assuming it is R SO2, then R. It means if here is methyl, here must be what? Must be methyl. If here is propyl, here must be propyl. But as long as there is something we call R prime, it cannot be so. So if here is ethyl, if here is methyl, here will not be methyl. So here will be what? Ethyl or propyl or butyl or any other compound. So this is something you are expected to know generally about nitroalkane, amines, nitrile, thiols, sulfide, and what? Sulfone. Nitroalkane is R bonded to NO2. Amine, they are the alkamines or they are minor alkanes. For the nitrile, I said they belong to the cyanofunctional group, which is carbon triple bonded to N functional group. Whereby thiols, I said they are alcohols that oxygen is removed and replaced by what? By sulfur. Sulfide, they are ether. Ether, please, there's a difference between ether and ester. Ester is carbonyl, but ether is not carbonyl. What I mean by that is that ether is R O what? R, but ester is R C O O, and here's what? R, which can be prime or not. Then we have the what? The last one we have there is sulphones. So like what I said, sulphone is formed from the oxidation of sulphide. It now give us sulfoxide. Then sulfoxide will now further oxidize again in place of hydrogen peroxide to give us what? Sulphones. So the R that can be the same. If they are the same, you use the word di. If they are different, you call them you name the smaller one before the bigger one. Like what I made mention of, you can't call it propyl methyl. No, it should be methyl before what? Propyl. What I mean by that is, if you have something like CH3 and here is S and here is C2H5, it is wrong for you to say ethyl before methyl. It is best to use methyl, ethyl, then what? Sulfide. Then assuming here is O2, it now be methyl ethyl what? Sulfone. Assuming you now remove one of the oxygen here, one of the oxygen is now methyl ethyl what? Sulfoxide. So let me give you something real quick again. If you have CH3, here is S, here is CH3. We can call it methyl sulfide or dimethyl what? Sulfide. When you now put O here, which is oxidation of that first one of a sulfide, is going to give us sulfoxide. So this sulfoxide is dimethyl sulfoxide. And if I put 2O here, which is 2 oxygen here, for the complete oxidation is going to give us dimethyl what? Sulfone. So please take notes. Sulfoxide, in between the sulfide we have sulfoxide, then after the sulfoxide we have what? Sulphones. So this is a general overview of what nitroalkane, amine, nitrile, thiol, sulphide, sulfoxide, and sulphone is all about. I have a question real quick. What the dehydration? I want everybody to think fast. You are going to get this answer. Let me not use the word dehydration. The reduction of sulfoxide, will produce dash. So when sulfoxide is being reduced, what will be the product of the answer? What will be our product? So please, if you know this, feel free to drop that in the comment section. And if you have any questions regarding what I've explained so far, please drop that in the comment section. I'll be there waiting for you to answer all your questions. Thanks for watching. I hope to see you in our next episode. But for now, as usual, goodbye.